Okay, so let's take another question. This is again a very, very well-known question. So it says that there are n stairs. Okay. Before we move on, let me tell you, by now you must have realized that the backbone of DP is recursion only, right? And in recursion, what is it that you do? You come up with some kind of recurrence relation, that how your bigger problem is dependent upon smaller subproblems. When you think of that, then you come up with an equation, right? So that should be your first step. That should be your first step in any problem. Because once you are able to write recursion, then you just have to memorize that recursion. Okay, over the time you will get it. So let's say there are n stairs. Let's say n is equals to 3 for now. So you have got something like that. And there is a child standing over here. And this child can either take one step or two steps at a time. I would say jump. So either he can take a jump from here to here, or he can take a direct jump from here to here. Okay. Now you have to tell me that how many different ways are there to reach the top. So I want this child to reach the top. And the thing to bear in mind is that at any instant, this child can either take 1 unit jump or 2 unit jump only. Okay, he cannot come down, he cannot take 3 units jump. So tell me, in this case, how many different ways do you see? So it's very easy to figure out. So first way is 1 unit, 1 unit, 1 unit. I can even write it as it is a unique path, different from all the others. I can write it as 1, 1, 1, because all the units are 1, 1, 1. Okay, second way could have been 1 unit and then 2 units. So I can write it as 1, 2. And then there is one more way, 2, 1. So this child could have first taken a 2 units jump and then a 1 unit jump. So it could be written as 2, 1. So these are the 3 distinct ways to reach the top. Now, how do I solve this problem? So before you think about DP and all, top, bottom, this and that, just clear the clutter from your mind and think about it very clearly, that is there a way I can express this problem in terms of smaller subproblems? So forget about number of ways to climb n stairs. Think about number of ways to climb fewer than n stairs. So I'm going to draw something separately over here. The target should not be to learn solutions. The target should be to learn how to think. Okay, so that I'm going to help you out with here. So listen very carefully. See, if there was a big staircase, I don't really care how big. Okay, and then there was a boy standing here. Now tell me one thing. I want this boy to get to the top. Okay. My simple question to you is, every path that has been taken, it can be written as a sequence of 1s and 2s, right? Now, what would have been the last step or the last number of any sequence? The last number of any sequence would either have been 1 or it would have been 2, nothing else than that. What does it mean? It means that the boy would have gotten here by making a last jump. I'm calling it by making a last jump of either 1 unit or 2 units. Boy would have gotten there by making a last jump of either 1 unit or 2 units. Now, if this is nth stair, tell me from which stair he would have gotten here by making 1 unit jump. From which stair? It would obviously have been n minus 1th stair. He would have made a 1 unit jump from here and then would have gotten here. Okay, from which stair he would have made a 2-unit jump and gotten at this location, it would have been from n minus 2th. So this is your n minus 1, this is your n minus 2. Now just think and tell me one thing. So let's say there are two family of sequences. First family is that which ends with 1, and second family is that which ends with 2. Can it ever happen that any sequence in this family is also present in this family? The answer is no. How is that possible? Any sequence that ends with 1 cannot end with 2 because 1 is not equals to 2, right? Now, what can I say? I can say that, hey, if I know how many different ways are there in which this boy can reach here, and how many different ways are there in which this boy can reach here, then my job is done. I repeat it. If I know how many different ways are there in which this boy can reach here, and how many different ways are there in which this boy can reach here, then my job is done. Because out of all the ways in which this boy can reach here, all those ways can be appended with a 2-unit jump, and that will lead the boy to this location. Similarly, out of all the ways that lead the boy to this stair, if I append those ways with a 1-unit jump, that will take this boy here. Now, what does it mean? It means that f of n is somehow related to f of n minus 1 and f of n minus 2. Now, what is f of n minus 1? F of n minus 1 is total number of ways to reach n minus 1 following this same rule. And f of n minus 2 is total number of ways to reach n minus 2 following the same rule. And we just realized that none of these ways will be equal to any of the way present in the other, because any way, any style of jumps in which the last jump was 1 unit, it cannot be equal to any style of jump in which the last jump was 2 units. Now, because both of them do not have any intersection, any commonality in between them, so whatever is their sum, that will be my answer. This is how this thing has come up. Now, this is exactly as Fibonacci, so it is super easy to write the, I would say, bottom top code for it. Okay, so what you can do is you can just say that let me initialize some values, and then you can follow up with other values. So if this is your stair number 1 and this is your stair number 2, can you tell me what will be your f of 1? How many ways to reach here? There is only one way, by taking a 1-unit jump. And what will be f of 2? How many ways are there to reach second stair? So in this case, what I was trying to say over here is what you can do is that your array of 1 will be 1, because you want your array of 1 to denote how many ways are there to reach stair number 1, and there is only one way. Similarly, number of ways to reach here is this, that, and this. So you can say array of 2 equals to 2. Now, after you have done these two initializations, then you can write a for loop which follows this rule. Okay, and then whatever will be the last element of your array, which is array n, that would be your answer. Now, the same logic you would have coded using top bottom as well. Nothing special about it.